We will now move on to our next honored speaker today. That is going to be Lee. And Lee Steinke is the Chief Operating Officer at Cislunar Industries and the interim COO at Orbit Fab. Both companies have government and commercial contracts to develop new technologies that enable space sustainability. During her career in aerospace and energy, Lee has scaled multiple businesses that leverage new technologies. As a partner to the U.S. Space Force, she led the Space Futures Workshop with industry to explore commercial views of the future of space. Lee is well published on a variety of technical topics and has become a sought-after speaker since honing her skills as an early producer and host of Conversations for the Future. So Lee, it sounds like you used to have this job here. Actually, I've seen some of your past videos. You did a great job. It's so nice to see you and welcome.
Thank you so much, Rebecca. It's delightful to be back, and it's fun to have that legacy and to see that my shoes have been filled beautifully, and we march on toward the future.
We march on. And just a reminder today, we have an intimate setting here in the Zoom room, and we are streaming live on LinkedIn. So we do have many listeners who are catching us on social media, and this your presentation today will be forwarded to YouTube as well. So welcome, and we are honored to have you. Please go ahead and start your presentation, Lee.
Thank you so much. And I have to say, I'm fangirling over Mariska. She and I worked on some things for the UN Space for Women mentoring program, and just she's a wonderful force for our industry. So let me share my screen. Got that. All right, can you see that?
Yes, we can see it, and it is in presenter mode.
Great, thank you so much. All right, so I am COO of Cislunar Industries. We do metal processing in space for space. We were founded in Luxembourg out of ISU in 2017 and moved to the US, Colorado, in 2019. So we've been a US company now for a good several years, and we've grown. I was the 5th employee at Cislunar Industries, and we now just hired our 11th full-time and part-time. And our team, even though we're excited about the future of space and we are aligned on our vision of the next industrial revolution in space, we are doers. We have backgrounds in real industries, terrestrially, building things, doing things, measuring them, and doing business about them. So we're really excited about making some of the ideas about space and the technologies and capabilities that we're developing real in terms of business and economic activity. We have developed hardware. We have multiple working prototypes of multiple systems, including our Modular Space Foundry, which is a microgravity version of terrestrial Foundry in miniature. We have our modular configurable electric power converter, electromagnetic induction furnace, and a continuous casting subsystem that allows us to make rods of indeterminate length in space. We have closed over $3.5 million in dilutive and non-dilutive funding, including a Space Force contract that we just got, a direct to phase 2 orbital prime for $1.7 million over the next 15 months. We've met our first milestone on that contract already and excited to be working on that with our partners, Astroscale, Sierra Space, and Colorado State University. We have received $925,000 in NASA contracts. We are currently on our phase 2 with partners NanoRacks, KMI, and School of Mines, Colorado School of Mines, a great force in space resources. So excited to be working on that. And there's a picture there of our first mission, which was a parabolic flight to test some of our subsystems in microgravity, and actually variable gravity is really the best way to describe that, which was part of that phase 2 NASA SBIR. We've raised $665,000 in friends, family, angel, investor type dilutive funding. And then we've received a grant from the state of Colorado. They do an advanced industries grant for about 5 or 6 different types of advanced industries, including tech, advanced manufacturing, and aerospace. And we were one of the aerospace recipients. And now I actually am a judge on that program in the next round. So it's exciting to be part of that economic encouragement by government on these technology and capability developments. We also have an active commercial contract, which is new. We earned our first revenues and put a check in the bank for for February. So that's exciting for a space company with a long-term vision to have survival mechanisms in place now. And we have money coming in for an additional government contract that we're finalizing the terms of right now. So really exciting progress since I arrived. I'm so proud to be part of the company. So what do? We have in-space salvage and recycling, in situ processing of mined materials. So basically what we're saying is we can take both man-made and natural materials through our foundry. And then we can do end-of-life disposal of sensitive assets. So I'll leave that in air quotes for Tim to interpret with his background. And the products that we make from those services include the materials that you might get from a steel mill, so wire, rods, tubes, sheet metal. But also when we make those rods, if we make them in a particular way, they can be used as metal propellant in a certain type of thruster for in-space transportation. And so that particular aspect of it is really exciting. So we're not only developing materials, providing materials to our customers, but also logistical capabilities. And then, of course, we can sell our technologies as well, the state-of-the-art furnace, casting, electronic and electromagnetic technologies, which have various terrestrial and in-space applications beyond what we're using them for. So you might ask, why are we doing this, right? Well, metal is expensive to launch from Earth and to deorbit as well. So as we know, when we talk about ADR, active debris removal, that's an expensive prospect that requires regulatory pushing. And so we realize there's cost on both sides of that value chain. It's also limiting to launch metals from Earth because they're limited in size and shape, because they have to fit in the payload of whatever they're being launched in. Finally, metal space debris is hazardous and sensitive. We lack the business case for deorbit, but we have new regulations that are pushing the 5-year rule, for example, which requires people to deorbit or in some way dispose of dead satellites within 5 years of their becoming not operational anymore. Metal waste crowds space stations. So we can say space station singular now, but at some point it will be plural. And the experiments that come up right now have boxes on them with corners that are made of aluminum and protective casing, and those aren't necessarily important to deorbit with the experiments when they're sent back down to Earth, but we do it anyway right now. And if we could turn that into something else in space, that would save mass on the down mass expense. And finally, metal can also be sourced in space. So man-made, lunar, planetary, and asteroid material can all be sourced and turned into something useful for us today. So Cislunar Industries, a lot of people ask us, well, how are you going to get the space debris to you? How are you going to get materials to you? And we fall right in the middle of the value chain. So we have partners like Astroscale, KMI on our various government contracts, but we have partners who capture debris, bring us the materials that need to be processed. We have partners on space stations who are going to host our platform. And so we don't do real estate, we don't do transportation or logistics. We only do the foundry operations of converting metal from one form into another. Then somebody can take it to customers, distribute it, and use it for manufacturing or transportation. Why now? So we've got, there are people who started years ago on projects that weren't able to survive, and we've got people who will come up with new ideas in the future that will have the momentum that we've helped create. But really, today is an excellent time to be starting this process. We have found, because we've been around since 2017 with talking about these things, and right now there's a real turn happening. There's a $4 trillion space economy predicted by 2040. NASA is committing $8 billion for space stations and the moon. And the DoD is just signaling huge demand. I like to joke that they're not just demand signals, they're demand sirens, is what we're calling them, because it's just so loud. The entire conversation at the Space Warfighters Lunch at Space Symposium last week was about refueling and in-space logistics. And both companies I'm working for are active in that space. It was just so exciting to see that kind of pull from a real customer. And finally, regulatory bodies reduce tolerance for debris. So there's a lot of movement on, this new 5-year rule. What are we going to do about space debris from a regulatory standpoint? So very, very exciting there. On the NASA funding that I talked about on that second bullet there, we are actually partners with all of the NASA funded space stations in place and starting to build partnerships with the lunar folks as well. How do we do it? So the Modular Space Foundry is our patented, in fact, I think our patent is actually being issued today. All the claims on it were approved a couple of months ago, but we just today, I think, is the magical day when we actually get our patent issued. So very excited about that. We receive, the model here is that we receive feedstock from our partners, whether it's man-made or natural material. And it needs to be cut down and manipulated into cartridges or through our program into the furnace, which will melt it down using our various set of capabilities. And then we have end effects that will produce the different materials I mentioned. So rods, tubes, wire for 3D printing, sheet metal in the future. And actually one of our rods has been sent to Australia, where it was tested in front of a live audience in a vacuum arc thruster from Neumann Space. Who developed that technology, and it generated thrust in a vacuum chamber there in Australia while we were all on the phone. It was really exciting. Now, the use cases, I've talked a little bit about this, but just want to get back into it. We're first recycling of waste metal on space stations into wire for 3D printing for space station customers. There are a number of companies developing 3D printing technology for metal and for in space, including Airbus, Redwire, and a number of other companies. And we're talking with them and working through the space station owners to provide materials for those customers. We are recycling space debris into in-space structural elements, and we have NASA contracts, our Phase 2 NASA contract for that. And then recycling of space debris into metal propellant, which is what our Space Force contract is. And finally, processing of lunar regolith into ingots of mongrel alloys. We like to call them mongrel alloys, the little mutts running around. We have different metals combinations on the moon, and there are lots of people working on the mining technologies of processing mined materials into final products. One of those steps is called beneficiation. It's a real challenge on the moon because the materials that we use terrestrially are not all available. And so some of those methods will have to be changed. We'll have to look back hundreds of years to see how we did it before we figured out all those modern processes and chemicals. And so there's a long future ahead of figuring all that out. Lots of good problem solving. So on our metal propellant, just wanted to go into a little more detail about our space debris to delta V concept. So this is taking metal and you could have an ADR spacecraft, an active debris removal spacecraft, or other spacecraft, and it could have a Foundry on it or hosted at a space station, which is our earlier model. And it's putting around, going to pick up debris or do other activities in space, and we can actually take that debris, melt it down, and turn it into a propellant rod, which then is put into the Neumann thruster, or there are now several other companies using metal propellant, and basically refill that spacecraft's gas tank with metal propellant. And the exciting thing is that it really only takes, less than 10% of the material of a specific piece of debris to do that round trip of going to get the next piece of debris. So it's very efficient. There's lots of material, 90% plus of the material is left over for manufacturing and other transportation uses. Cislunar Industries is partnering across the ecosystem today with lots of different companies and government agencies, and starting to talk to international partners. And it's just been really exciting to see all the response, right? I mean, we're a small company, but we're actively working with larger companies, and I'm able to be a partner with a lot of parties that we've looked up to over the years, and it's just really fun. Industry is creative and open to collaboration at this phase in our life, and I think that's an important step. There will be times when the industry will get more competitive, and that will be appropriate too at the right time, but right now is a time for building partnerships and advancing that space ecosystem and the space economy by almost any means that are appropriate for economic development. And then we'll sort of fight out who owns what and how the chips fall going forward. Now, we're always looking at how our programs spin off into other products because, I like to say survival isn't a distraction. A lot of people call spin-off products and early revenue attempts distractions. And I agree, you have to be careful in how you pursue those and how you allocate resources to balance your short-term survival with long-term vision. But survival really isn't a distraction. And we've looked at our products and services to see what we can do today to earn revenues to help ensure our survival through our long-term vision. And one of those exciting products is the converter, the power converter that we developed to take power from our solar arrays, the solar arrays of our host, real estate, a space station or a lunar base, wherever we are, into alternating current for our induction furnace. And what we did, we talked to some customers. We were at Colorado State University working with them on this program, and they said, hey, this thing you've built looks a little bit like what you would put in a power processing unit for propulsion on a satellite. And we said, really? And so we started researching that, and we have now, in the last 2 or 3 months, we went and built a power processing unit out of one, and we went back to CSU and we put it in their lab and ran a thruster on it, a Hall effect thruster on it, and it ran at a very high efficiency and is smaller and lighter than what people are using in space right now. And so we are working with new customers, a whole new batch of types of customers that we hadn't really been working with before, who are interested in bringing these to market with us, and just really fascinating to see the evolution there and the ways that people make decisions about their in-space hardware, right? And why that leads to slower technology development in some cases, strangely enough, than you might expect, and how perhaps a little guy can disrupt that market with a product that's differentiated. So our roadmap is we got our NASA contract in 2021, and we did our live demonstration of our prototype rod maker way back during our NASA phase 1. Most phase 1s do not involve hardware development, but we wanted to overachieve. We're a group of makers, and so we did that, and I got to see the live demonstration. That was before I went to work there, and I was just so impressed with the team and the cojones that it took to do a live demonstration of such an early phase prototype, and it went beautifully. 2022, we got our phase 2 contract and built more prototypes, and we got to fly in November on a parabolic flight mission, doing testing of our magnetic steering, continuous casting subsystems, and we made a kind of sort of rod, so we'll know what to do better next time to get a full rod. But we learned a lot from that. We demonstrated that we could manipulate and stir metals using our magnetic steering array, and so really exciting progress there that has next steps that we're already working on. In 2023, we got our Space Force contract, and we've already met the first milestone there and received our first payment, which was very helpful for a little guy like us. And we'll have our second parabolic flight, and we plan the first sales of our power converters, PPUs, in the second half of 2023. In 2024, we have an ISS demonstration of the Foundry system and orbital demonstrations of our propellant rod and power converter. And then in 2025, we have our first commercial revenue for recycling of waste metal on the ISS. So really fun to tell you all about it. It's been so long since I've been back, and hoping that my friends are in the audience here, and it's really nice to see some new faces as well. So thank you for having me, and look forward to your questions.
Lee, thank you so much. What an amazing mission you all are on over at Cislunar Industries. This is the key that we've been looking for to start recycling in space, because we recycle here on Earth. We know it can be done. And look at you all, you're recycling waste metal and turning it into propellant. That's amazing. And truly, that's a huge breakthrough for the space, for space migration and for space exploration. So wow, that is very neat. We are open. The floor is open to questions. If anyone has questions, they can raise their hand or put it in the chat. And then Sarah did ask about something you addressed with the 3D printing. And so could you talk more about how your work is also aligning with 3D printing?
Yes. So in that first model, basically, people are sending up experiments to the space station all the time, and we're including 3D printers. So I think Airbus's 3D print test is on the ISS now, or has recently finished its tenure up there. And basically what we can do with these experiments, they often have metal casing, a metal box, or corners that reinforce. So, you bring up a box of spiders, and you got to reinforce it somehow, because you're going to have plexiglass, and often that comes up in metal. And what's happening now is they're spending money to downmask the whole experiment, including the metal casing or whatever parts are metal. And it costs twice as much to send it back down to Earth safely as it cost to launch it in the first place. And when I learned that, I was just blown away. It seems so silly, but that's the fact of it. I guess the heat shields, the programs that deorbit are, there's less capacity, and as a result, it's more expensive. And so we had this concept. Actually, a customer came to us with this concept. It was not our own idea. So we know there's demand for it, was to take this metal and not downmass it and save money for the customer, and instead take that metal waste and cut it into the right shape to go into our modular space foundry, which will then melt down the metal using induction heating. And terrestrial foundry operations rely on gravity to pour the molten metal. And so one of the features of the modular space foundry is that we've replicated the pouring technology with this magnetic steering capability. So we use magnetic fields. It's kind of like, a force field like in science fiction. We use an array of magnetic fields and how they interact in order to manipulate the motion of the molten metal that we've melted with the same induction coils. So it's a really interesting dual use, no pun intended, case of the use of our technology. And from that, we manipulate the metal into the pouring capability, which will then create an ingot, basically, or a rod. And the rod can then be drawn, the process is called drawing, into a wire. So you basically stretch it out, and you can find YouTube videos about cold draw, warm draw. There's a variety of methods for turning rods into wire. And the first metal we're working with is aluminum, which doesn't make great wire, but there will be developments and different alloys as we get more capable and start to look into the chemistry of what's going on in space. And so we can draw this wire using end effectors on our system and deliver that to the space station, back to the space station. And that can be done as a service where we don't actually ever buy the material as Cislunar Industries. We just are paid to change the shape of the metals that we have. And then those can be fed into the 3D printers that then can develop whatever people want to be made of metal in space.
Wow, so magnetics, that is it's so innovative, and yet it makes so much sense once you explain it. That is very, very cool. I imagine that you feel inspired often when you get to step back and look at the work that you're doing.
Oh, it's fantastic. In fact, my mom used to always come to Conversation for the Future every month when I was on, and when I went to her with our first, I got a sample of some of the early rods that we made with our very first prototype when I first started working here. And I brought them to, I took them to everybody, showed them to all my friends and family. And my mom said, can I have this? I want to show it to my friends. And being the savvy business person that I am, I said, no, you can't have it, but I'll sell it to you. So our very first revenue ever, our first commercial revenue from a customer, not our first ever revenue, but our first commercial revenue was actually a check from my mom for $100 where she bought the 2 rods. So yes, people get excited about in-space metal.
Yes, they sure do. And I hope that you took a copy of that check and you framed it and it's on someone's wall somewhere just to remember your first commercial sale. That is very cool. Lee, I have a question for you. And before we let you go today, we're also going to give you a chance to share something that you wrote. So we do have that coming up. My question is, how can our work here at Foundation for the Future, we are focusing on space infrastructure, and clearly we align with the the desire to be sustainable in space. We're bipartisan, and we want to please as many actors as we can in this this striving to build infrastructure in outer space. So what advice do you have for us here at the Foundation as we work with Congress, as we develop partnerships, and how can we do better in the industry, and how does that relate to you all?
Yeah. So one of the reasons I liked working for Foundation for the Future was that vision of space infrastructure. As I mentioned early on, I like to do real things. I've been in heavy industry, and I think it's important to get energy infrastructure, going so that we can then do the other things that need to be done in space. And Cislunar Industry, because our capabilities to reform metal, to provide construction materials of possibly, kilometer length rods. We can do things that haven't been able to be done before. So we're excited to be part of that. In terms of advancing the legislative and regulatory environment for space, our particular goals, we've been to the White House to talk to them about the development of ISAM, the in-space servicing, assembly, and manufacturing industry. And our regulatory priorities there are to advance something that will allow there to be the transfer of ownership and liability in space. So right now, the liability of existing assets in space, old stuff that's been there already, is a challenge. And we want to develop some rulemaking there that allows us to receive and take on liability and ownership, or for our partners to do that so that we can work as a service. That's going to be an important step. So that's number one. The second is we want to allow salvage yards to be to satisfy the 5-year rule. So we want not just deorbit, not just putting in the graveyard orbit. We want one of the check boxes that you can pick for your end of life plan for the 5-year rule. We want that to be that you can come to a salvage yard where we can hold you, we can recycle you immediately, we can repurpose you, or we can sell you to somebody else. So
Brilliant.
Those are our 2 regulatory priorities.
Brilliant. I love it. And you already have been in touch with Maruska. Maruska and I studied space law and policy at Harvard University, and that's our concentration. So if you ever need any cheerleaders or any help with that, we are on your team, Lee. And wow, such good stuff today. We want to give you a chance to share a poem that you wanted to share with all of us today as we wait for our final speaker today. So go ahead, Lee.
Thank you so much. So I've been inspired by space in my work over the last 2 years, and every now and then that inspiration turns into something different. And in this case, it turned into a poem. This one's called Propellant. Premeditated chemistry, a custom formula tuned for a singular purpose, to go up. Noisy as hell and demanding attention, reckless combustion unclipses a toy sun and raises it through the pre-dawn sky. A spectacular beacon tethering hearts to its ascent, pulling them from drowning in a suffocating deep of breathable air. The impetus is enough to escape from Earth's gravity well, from whatever it is that holds us down.
Bravo, beautiful. That's just, did you write that?
Yes.
Oh, and you clearly have practiced, and sounds like you may even be one of those what do they call the poetry slammer? Are you a poetry slammer? That was so beautiful.
No, this is one of my first times reading a poem in public, so I've thought about maybe doing that, but I thought you would enjoy hearing that one. And
don't quit, and have it in your pocket anytime you go to a space conference. We'll give you the mic so that you can give us our moment of inspiration and art, because STEAM is so important, putting that art in STEM. Thank you, Lee, for being here today. What a beautiful poem and what a great presentation. And we will see you at the next one. And please let your mom know that we're still here, so she can come on over anytime. We're here twice a month, every month.
Thank you so much. It was
Thanks for being here today.